Hi everyone, this is Mr. Siu from Math Accelerator and welcome to P3 SA2 Mini Revision Lesson 4. The topic we're going to cover today will be measurement, and the heuristics will be comparison model, and number 2, gaps and interval. Let's go to the first question. Right, this question involves multiplication and division. Let me read the question to you. In the diagram below, each wooden block is of equal mass. The mass of 6 blocks is 852 grams. Find the mass of the jar. Alright, so let's see what we can highlight some keywords over here. We know that we have wooden blocks that are of equal mass, and 6 blocks is 852 grams, and our objective is to find the mass of a jar. Alright, so let's organize our information over here. If 6 blocks is equals to 852, then we need to find one block. To find one block, we will take 852 divided by 6. So let's carry out our working at the side here. 852 divided by 6. 1 times 6, 6. 8 minus 6 is 2. Bring down 5. 4 times 6 is 24. Minus, we left 1. Bring down the last 2 over here. And we know that 2 times 6 is 12. Once we do the subtraction, we get 0. Okay, so we know that each block is 142 grams. Now we notice that over here, we have 2 blocks. 2 blocks in the jar will give us the same mass as these 6 blocks here, which is 852. So next we have to find the mass of 2 blocks. So we write over here 2 blocks will give us 142 multiplied by 2. 142 multiplied by 2. 2 times 2 will give us 4. 4 times 2 will give us 8. 1 times 2 is 2. So these 2 blocks will have the mass of 284 grams. Next, we form our equation. We have the jar plus 284, and that will give us 852. So next, in order to find the mass of the jar, we have to take 852 minus 284. Okay, let's work out over here. 852 minus 284. 2 is smaller than 4, so we borrow from 5. 5 becomes 4, 2 becomes 12. 12 minus 4 will give us 8. 4 is smaller than 8, so we borrow from 8. 8 becomes 7, 4 becomes 14. 14 minus 8 is 6, and 7 minus 2 is 5. So we know that after our calculation, we confirm that the mass of the jar is 568 grams. Right, this question involves 3 operations, right? Number 1, you have to do your division. Number 2, you have to do your multiplication. And the third one, you have to do a subtraction, right? So these are the 3 steps that you need to cover in order to reach for the answers. Okay, let's recap what did we do. Number 1, we highlight the keywords. Let's write here keywords. Then we organize the keywords over here. And lastly, we carry out the steps. Okay, what are the steps that we cover? We cover number 1, we did a division. Number 2, we did a multiplication. And number 3, we did a subtraction in order to get the answer. So we Focus on the balancing beam. You can see that over here, a jar and 2 blocks can balance with 6 blocks over here. And we know that this 6 blocks is 852. Therefore, the jar plus the 2 blocks will give us 852. Based on our calculation, the 2 blocks here has the mass of 284 grams. Therefore, we subtract this from the total mass of 852 and we found out that the mass of the jar is 568. Let's move on to the second question. This is question 2. So in question 2, we will be using comparison model. Let me read the question to you. Bottles A, B, and C contain 1,350 ml of apple juice altogether. Bottle A contains 100 ml more apple juice than bottle B. Bottle C contains 250 ml more apple juice than bottle A. How much apple juice does the bottle contain? So after reading, let's underline the keywords. The keywords will be, this is the total volume of apple juice altogether for these 3 bottles. And we have a comparison in the second line that bottle A is 100 ml more than bottle B. The third line tells us that bottle C contains 250 ml more apple juice than bottle A. And we need to find how much apple juice does bottle A contains. So after highlighting the keywords, now let's organize these keywords into a model. So we can draw a comparison model because we have A is 100 more than B. So we will draw a bar model for A longer than B. Let's include A, B. The difference here is 100 ml. Next, bottle C is 250 ml more than apple has 250 ml more apple juice than bottle A. So we're going to draw bottle C longer than bottle A. So over here, this is 250 ml. Down here will be 100. And the total, according to the question, is 1350 ml. So the first thing we have to do is label 1 unit here. As you can see, we have 1 unit, 2 unit, 3 unit, and these 3 numbers here, right? 100 ml, 100 ml, and 250. So we can see that these 3 units plus these 3 measurements will give us a total of 1350. So our objective is to find the mass of these 3 units here. 1, 2, 3. So in order to do that, we have to take away these 3 numbers, right? 100, 100, and 250. So let's add at the side here. Okay, 100 plus 100, we will get 200. And then 200, we need to add 250. So we will get 450. So let's write the equation over here. We have 3 units plus 450, and that will give us 1350. So next, we have to find the value of these 3 units. So we're going to take away 450 from the total. So 1350 minus 450. So 00 is 5 minus 5 will give us another 0. 13 minus 4 is 9. So we know that 3 units is 900. So next we have to find the value of 1 unit. So we'll take 900 divide by 3. So 3 times 3 is 9 minus left 0. So the rest are zeros. So we'll bring down. So we know that 900 divided by 3, we will get 300. So now we're going to find out how much apple juice does bottle A contain. So bottle A, as we can see, is 1 unit plus 100. And we have calculated that 1 unit is equals to 300 ml. So we will add 300 with 100, and we should arrive at 400 ml. And that's the answer. Okay, let's recap what did we do. Okay, we went through this routine called KOS. As mentioned previously, K is to highlight the keywords. Okay, over here we highlight all these keywords here. O is to organize the keywords. And we organize in the form of a model. And the third is the steps that we need to take in order to reach for the answers. We carry out these 3 steps. Number 1, we did addition, where we sum up these 3 numbers. Number 2, we did a subtraction in order to find the value of these 3 units, because we're going to take away these 3 numbers. Then we did a division, right? Division. So the division, we take 900 divided by 3 to get 300. And lastly, we did a addition, okay, where we add 300 to 100 to find the volume or the mass, the volume of the apple juice that bottle A contains. So this is a thinking routine that I always encourage students to use whenever they are whenever they are solving problem sums, right? Problem sums. Then this is a very structured approach so that you are able to go through the steps in a systematic manner. Number 1 is to highlight the keywords. Number 2, you organize the information. And number 3, you carry out the steps. Right? Practice this, and I'm sure you'll be able to improve on your accuracy and efficiency when you are solving long-form problem sums like this. Let's go through the third question. This is the third question. So this involves gaps and interval. Peter placed some pins along a straight line with an equal distance between each of them. The distance from the first pin to the ninth pin was 40 cm. The distance from the ninth pin to the last pin was 50 cm. Find the distance between the first and second pin. How many pins did Peter place along the straight line? Okay, after reading, remember we have to underline the keywords. We know that we have 9 pins altogether, first to the 9. And the distance is 40. The distance from the 9th pin to the last pin is 50 cm. Find the distance between the first and second pin. So we will make use of the first set of information here to solve part A. So let's go through this understanding. We know that if we have 2 pins, there will be 1 gap. And if we have 3 pins, we have 2 gaps, right? So 2 pins is 1 gap. 3 pins will give us 2 gaps. You begin to see that the number of gaps is 1 less than the number of pins, right? So if we are told that the first 9 pins has a 40 cm distance, therefore we need to find the number of gaps for the 9 pins. And 9 pins, since it's 1 less, we'll take 9 minus 1, we will have 8 gaps. Right, 8 gaps. So 8 gaps, these 8 gaps will have a distance of 40 cm. So now Using this information, we will be finding the distance of one gap. So one gap, we'll do a division, 40 divided by 8, and we will get 5 cm. So that's the answer for part A. Find the distance between the first and second pin, right, which is one gap. And we arrive at the answer, 5 cm. Part B, how many pins did Peter place along the straight line? Now, in order to do that, we have to find out for part B, the total distance, right? The total distance, we have to sum up 40 cm and 50 cm. So 40 plus 50, that will give us 90 cm. So let's go back to what we have constructed here. We know that 2 pins will give us 1 gap, and 3 pins will give us 2 gaps. So the number of gaps is related to the number of pins. And we also find out that 1 gap, or each gap, is 5 centimeter. So next, if we have 90 cm, our next job is to find out the number of gaps in this 90 cm. So let's write here, number of gaps. Because if we can find the number of gaps, then we will be able to tell how many pins did Peter place along this straight line. So we will take 90 divided by 5, which is the distance of 1 gap. Let's do our working at the side here. 90 divided by 5. So 1 times 5 is 5 minus 9 minus 5 is 4. We bring down the 0. So 40 is 8 times 5. 8 times 5 is 40 minus left 0, right? So we will have 18. So 18 gaps. So how are the gaps related to the pins? The gap is 1 less than the pin. So if we have 1 gap, 1 plus 1, that means we have 2 pins. If we have 2 gaps, 2 plus 1, we will have 3 pins. So if we have 18 gaps, and we know that the number of pins is 1 more than the number of gaps, so we'll take 18 plus 1, and we will get 19 pins. So there you have it. We found out that Peter has 19 pins placed along this straight line. So that's the answer for part B. Okay, let's write the answers over here. Part A, we calculated that each gap, or the distance between the first and second pin, is 5 cm. And the second one, okay, how many pins did Peter place? 19. 19 pins. So let's recap, what did we do? Number 1, keywords. We highlight some of the keywords. Number 2, organize. We organize this keyword, okay, and the information from the diagram over here to help us understand the relationship between the number of pins and the number of gaps. So once we establish the relationship, okay, we will be able to tell that 9 pins, there are 8 gaps. And if this 8 gaps is 40 cm, we are able to find the distance of 1 gap, which is the distance between the first and the second pin. So 40 divided by 8, we get 5. Next, we need to find how many pins did Peter place along the straight line. So the total distance is 90 cm. So we will find the number of gaps. So we take 90 divided by 5, we get 18. So 18 gaps, 18 plus 1, then we arrive at 19 pins. Right, that's the end of today's lesson. I hope you find it useful. So keep practicing, and I'm sure you'll be able to be more confident when you approach these problem sums. Thank you, everybody. I'll see you in the next video.